Did you know that the same type of reaction that makes iron rust also keeps you alive? Hi and Assalamualaikum everyone. Have you ever wondered why iron rust, why batteries power your phone, or how your body produces energy? The answer lies in something called redox reaction. And so, what is redox? Redox stands for reduction and oxidation. These are chemical processes where electrons move from one substance to another, whereas oxidation means losing electrons, while reduction means gaining electrons. And here's the key, they always happen together. It's very important as redox reactions are everywhere. When iron rusts, that's a redox reaction. When you light your fire, that's another one. Even inside your body during respiration, redox reactions help release energy from food. And in technology, batteries and fuel cells rely on redox to store and deliver power. In this video, we demonstrate several experiments that explain how redox reactions occur, including the role of water and air in metal rusting and how oxidation causes apple browning. Let's check them out.
Now, let's talk about how apple oxidation experiment was prepared. First, we need 4 different solutions, which were sugar solution, lemon juice, sodium bicarbonate solution, and salt solution. Next, an apple was cut into 5 equal slices, and 1 slice was placed on a plate without soaking in any solution and served as the control. Meanwhile, the remaining 4 slices were soaked in different solutions, such as sugar solution, sodium bicarbonate solution, lemon juice, and salt solution for 1 minute. After 1 minute, all soaked apple slices were removed from the solutions and placed on a different plates. Then, all apple slices was exposed to the air for 15 minutes. After 15 minutes, the color changes of the apple slices in different solutions were observed and compared with unsoaked apple slices. Have you ever wondered what caused the browning of the apple slices? The browning of the apple slices is caused by a chemical process called enzymatic oxidation. When an apple is cut, the inner surface was exposed to the oxygen in the air. The oxygen reacts with phenolic compound in the apple in the presence of enzyme called polyphenol oxidase. This oxidation reaction produces brown-colored compounds that turns the apple slices into brown color. Also, the rate of oxidation can be affected by different solutions. For example, acidic solutions such as lemon juice can reduce the activity of the enzyme and slow down the oxidation. Meanwhile, sugar solution can reduce the exposure of the apple surface to the oxygen. However, salt solution and sodium bicarbonate solution are less effective in preventing oxidation that allow the reaction to occur. This explains why this experiment obtained this result.
It's a type of oxidation that happens when iron react with water and oxygen. Before the theory, we conduct experiment using 3 paper plate, 3 containers, hot water, boiled water, and cooking oil. We conduct the experiment by using this procedure. First, we prepare 3 clean paper plate and 3 clean containers before label them as A, B, and C. Paper clip A was placed into a container that filled with tap water and the container was left open. Paper clip B was placed into a container filled with boiled water before a layer of cooking oil being poured into the container and closed it tightly. Paper clip C was placed into a dry container without any water. The container for paper clip C was also being closed tightly. All of these 3 containers were left for 1 week each. After that, we observed the clip to see whether rust had formed. From our observation, the paper clip in container A show rust on its surface. This happened because the paper clip was in tap water and the container was left open, so both water and oxygen were present. Iron need both water and oxygen to rust. This helps oxygen reach the surface of the iron and chemical reaction take place. As a result, the iron react with oxygen and form rust. Meanwhile, paper clip from container B and C don't show any sign of rust. It is because water and oxygen are not present in that container. It is the solid proof that rusting occurs when iron is exposed to water and oxygen.
So here we with me, we're gonna discuss about what happened on these experiments. So, typically, this experiment was carried out to investigate the redox reaction through two everyday phenomena, which is the browning of apple slices and the rusting of paper clips. So basically, the apple browning is an oxidation process, which is phenolic compound in apple are oxidized in presence of oxygens, which is can producing brown pigments. So as we all know, in this experiment, apple slices were immersed in different solutions to observe their effect on the rate of oxidation. So we have sugar solution, salt solutions, lime juice, and sodium bicarbonate solutions. So firstly, we're gonna discuss about an apple slices in sugar solutions. At first, the browning still occur on the apple slices, although at slower rate compared to the untreated apple. The sugar solutions does not chemically prevent oxidation, but reduce contact between oxygen and the apple surface by performing a thin layer. As a result, the oxidation of the apple compound still occur, but indicating the redox reaction is not fully inhibited. Meanwhile, in salt solutions, browning was reduced more effectively. Salt, which is a sodium chloride, lowers enzyme activity by disturbing the cellular environment and reduces the availability of oxygen at the apple surface. This slows down the oxidation of the phenolic compounds, thereby slowing the redox reaction responsible for browning. For another solution, which is a lime juice, when the apple slices were immersed in the lime juice, very little or no browning was observed. It is because lime juice is acidic and contains ascorbic acid, which is a vitamin C, which acts as a reducing agent. This happens because ascorbic acid donates electrons to oxidized compound and react with oxygen first, so that it preventing the oxidation of phenolic compound. Therefore, the redox reaction causing browning is effectively inhibited. In contrast, the apple slice placed in sodium bicarbonate solution show the fastest and the most intense browning. Sodium bicarbonate creates an alkaline environment which increases the activity of polyphenol oxidase enzyme. These accelerate the oxidation of phenolic compounds, enhancing the redox reaction and causing rapid browning. Meanwhile, in the paperclip rusting experiments, rust performed when the paperclip was exposed to air and moisture. Rusting is also a redox reaction involving iron, oxygen, and water. This rusting happens when ions, which is an atom in the paperclips, lose electron and are oxidized to form an iron and iron 3 electron. This happens when oxygen gains electron and reduced from the presence of water. The product in this reaction combine to form an hydrated iron trioxide, commonly known as a rust. This shows that rusting is a clear example of redox reaction.
Today, I'm going to present about apple oxidation. First of all, what is oxidation? Oxidation is a chemical process that happens when a substance reacts with oxygen. We can clearly see this process when an apple is cut and left exposed to the air. Now, moving to the first question, which apple slice did not turn brown? The apple slice that did not turn brown is the one that was treated with a substance such as lemon juice, orange juice, and salt water. This substance helps prevent or slow down the browning process. Next, the second question is, why did the apple slice become brown? The apple slice became brown because of oxidation. When the apple is cut, the inside of the apple is exposed to oxygen in the air. An enzyme called polyphenol oxidase reacts with oxygen and causes the apple to change color and turn brown. Finally, the third question is, the substance can slow down the oxidation process. Substance can slow down oxidation include lemon juice, orange juice, salt water, and cold water. This substance work by reducing an enzyme activity or limiting the apple contact with oxygen. In conclusion, apple oxidation is a natural process, but it can be slowed down by using certain substance. This is why treated apple slice stay fresh longer than untreated one. Now we are on to the next experiment, which is rusting on the paper clip.
Why rust form on paperclip A? Rust form on paperclip A because both water and oxygen are present. The paperclip is immersed in tap water, which contains dissolved oxygen, and the container is open to the air, so oxygen can reach the paperclip continuously. Rusting occurs only when both water and oxygen are available, causing the iron oxidize. Now, we're moving to the next question. Which nail do not rust? Paperclip B and C do not rust. Paperclip B does not rust because it is in boiled water covered with oil, so oxygen is absent. Paperclip C does not rust because it is kept in a dry environment, meaning water is absent. Rusting requires both water and oxygen, so these two paperclips remain unrusted. Finally, we are moving on the last question. Why did paperclip B not rust even though water was present? Paperclip B did not rust even though water was present because oxygen was absent. Boiling the water removed dissolved oxygen, and the oil layer on top prevented air from supplying oxygen. Since rusting requires both water and oxygen, the absence of oxygen prevented rust from forming. Thank you.
So, we've learned that redox reactions involve electron transfer with oxidation and reduction happening together. Redox reactions truly power the world around us and inside us. They're not just abstract chemistry, they're part of everyday life, from rusting metals to powering your devices and even keeping you alive. If you'd like to learn more, dive deeper into how redox reactions are used in technology and industry. Thanks for watching and keep exploring the science behind the world. Have a nice day!